Hello everyone, how are you all doing? Great. So I hope you all are writing your Python code with me. But if you are not, or if you have just started from this video, so you can, watch the previous videos and you can easily catch up as we have just covered the basic of Python. Now, in this video, we are going to learn about Python data structures. So there are different type of data structures we will be learning about in the upcoming videos. But in this video, we are just going to talk about the one data structure, that is list, and we will be running few operations which we can perform on list data structure. So let's start. So let me change this to Markdown and I'll give the heading Python data structures. So data structure basically structures that holds data together. A data structure is particularly a way of organizing data in your computer so that it can be used effectively, so that you can use your data effectively. So these are very important. So basically there are four different types of data structures: tuples, list, dictionaries, sets, and we will be understanding about each of the data structures in very fair amount of depth. Okay, so stay with me and let's first start with list. So let's give one more heading here, and I mentioned list. So practically when you are handling your data, you are not given a single number or single data type, right? Your data does not have single data type. It can be string, integer, float, boolean, everything, right? So you are given a set of values and you are asked to manage them. Okay, so there are multiple data structures that can handle such set of values. Okay, so for that we need data structures. The data structures are to organize those different type of data and keeping their unique properties with them. So let's build an application which records customer details and assign it a unique user ID number generated randomly. Okay, so let's start. Let's write our first line of code. So that is name, and here I'm asking for user input. So let's type what is your name, and then second line of code is number. Let's take input from user input. What is your number? Let's run this code now. So first we'll provide the name Neha, enter, and number 9. Okay, so that's the input we have provided. Now print name, comma, number, and run the code. Okay. Now we have, let's use a library, random. So these are the two methods. Random is the library. So your Python has very huge library which with the help of which you can do lots of operations. So these are the libraries which we will be reading in future. So it's right now for this idea, let's talk about this random library. So this is random method which I'm going to use, and I'm giving number, starting number 100 and last 3-digit number is 999. If you just run this value and then you run it, so it will randomly pick a number. And if I want to print this name, number, and value, so the value, it will pick the value which you got from here and it will print it here. Now you see this name is string, right? This is not number and these are the numbers. Now if you want to store this data, now how will you store it? And then next there comes our list, because list can handle different type of data structures, data types. So let's create a list here. So you can define your list like this. So list you define in square bracket, all the values has to be comma separated, and that's how you can access different type of data types. That's how you can store your data in list. So this is the format, and list are most basic data structures available in Python that can hold multiple variables objects together. So your list are order sequence of mixed data type, okay, and list are written as comma separated within square bracket. It's clear, I think. Yeah. So I'm going to define a list here. Let's start with its introduction. Let's define a list as L is equal to square bracket. Let's say I'll define a string here. So India, say 15 is a number, 16 is a number, and then let's define another string, Delhi. Okay. And you want to print it, say L. Shift enter. So the list is defined. You have printed it. You can also have nested list. So this one is simple. Nested means one small list is part of big list, subset of another list. Means one small list values defined in a square bracket, and as an element they are defined in another big list, right? Let's define this nested list. L equal to square bracket and chemistry. Then you defined biology, and then let's define another list. So as we know, we define listing and close bracket, say 994, and then we have one more element in this list, in the parent list. So let's print this and shift enter. So you have this list. So this one list is defined in this outer list. So we call it nested list, right? Next is indexing. So we are going to learn about the various operations which we can perform on the list. So this one is indexing. So like I have already explained in my previous videos that how we do the indexing in Python. So there are two different types of indexing, forward indexing and reverse indexing. Forward indexing starts with 0 and reverse indexing starts with -1. So we have this list, right? This chemistry, biology, and this nested list and food. Let's see the output of 0. So this is the 0 indexing. Forward indexing starts with 0, right? So let's run it and let's see what value you get. Shift enter, chemistry. So this is your list and your first element is chemistry, right? So that should be the answer. Now let's say let's run 1. It is biology. Now let's try this -1. So this is reverse indexing, means we'll start from the back. We'll start from the last element, and that is 4. Now, what if you want to read this indexing? First, let's see. So this is -1 from the reverse indexing, and it should be -2. So if I do this, if I try to read this -2 position, then this is the list. So for this big list, this one works as one element. This is one element. From the starting at second position, you have this, and from the back -2 position, you have this one element, right? So it should be the value of L -2. Now, what if you want to read the first or the second element within this nested list? So how can we read it? So first we will give the position of this nested list. So first we will give the position for nested list, that is -2, and now at this position I want to read the 0 indexing element, this. So -2, it will go here, and now on this list I want to read the element which is at 0 position, right? Let's run. You know what should be the answer. Okay, so -2 is this list and 0 is this one. First element, first number is this. So that's how we do the indexing. Let's read the next is slicing. So you know what is slicing, right? So if you want to, access the one element, if you don't want to access the complete list, then we will use the slicing. So slicing is used when you want to use access only a component of the list, not the whole list, right? This is my list, right? This is your list. And now for slicing, I want to just fetch a component. So how will you do it? This in the square bracket only. and say I want to read 1 to 2. So 3. This third position is not included, right? When we do the slicing. So this is 0, 1, and 2. And this fourth is 3 position, 3 index position. So when I say 1 and 2, so 1 is included, but the 3 is not included. Okay. So first is biology, and second is this nested list. 3, the last number you defined, we don't include that. We include the element at the second last position. So whatever number you have first defined, that number being the last number, and you access the second last number. Okay. So 3 is 4, but we are not reading it. We are reading this second position only. So that's how your slicing work. Now let's go ahead. So membership. Let's check if a number is available. Let's define a new list here. L1, and in the square bracket, let's define 1, 2, 3, 4. Okay. Enter. Let's print it. 1, shift enter. So this is your list. So let's check whether number 1 is available in your list or not. So let's write this command, print. I want to check 1 in. So in is your keyword which you use to check in the string or in the list or anywhere. So print 1 in L1. So L1 is a string where I want to search. Let's run this. So the output it gives is either true or false. Say I want to search print number 15 in L1. Shift enter. Sorry, print shift enter. So false. For the first line of code, it is true. For second line of code, it is false. So it gives Boolean values as output. So that's how you can check, right? Now let's read about the concatenation. So there can be many scenarios where you want to update your list and you want to make changes in your list. So that's where we use concatenation. This L is the list, this chemistry, biology, and this is the list. Let's do the concatenation on it. So let me define the new list. New list is equal to, say I want to add 5 and 8 values here in this list. So I'll go and do L. L is the list on which I want to perform the concatenation, and plus define the list here 5 and 8. Now let's see what is the output of this new list. Shift enter. So you see the original list was chemistry, biology, this list, and 4. Now since you have concatenated it, you have updated the list. Sorry, I mentioned it 5.8. It's 50. So you have updated, you have concatenated these two values. So your list, this new list became this one. So 5 and 8, two different values got added. Okay, so that's how you do the concatenation. Now let's see if we can change the list, if we can replace some values in the current list. Replace. So yes, we can make the changes on the list, and you can update the values if by mistake you have defined something wrong, you have entered some incorrect values. So definitely you can change the values, you can replace those values and correct your list, right? So there's our mutable data types. So let's pick this L1. Say I want to replace the value at position 1 and give it to something else. Say it is biology now. Let's give it physics. Now let's see if we have this list updated. So print L. So you see your biology got updated with physics. Okay, so lists are mutable data type, so they can be changed. Next is extend. So if you want to extend your list, so there are two different functions I'll be telling about. So one is extend, another is append. So we'll read about both the functions and we'll see the difference. So let's see how it works. So I'm going to perform this action on list L only, and we do it like L dot extend, and within the bracket, let's define a string. Let's extend this L string with these values, say 10 and 12. Now let's see the output. Enter print L and shift enter. So you get this chemistry, physics, this list 5, 8, 5, 8, 10, 12. Okay, so 10, 12 got added. Now let's see this one function append. Okay, let's see how it works. It also adds the values within the list. Let's see how it works. L will perform the action on this list only. Append. Let's add this same value 10, 12, and let's see how it works. Shift enter. So this was my previous list. I have this 10 and 12 value added like a separate element, but when I appended it with this function, I extended it with this function, append function, so it got added as a nested list. Okay, so these two values got added like this. Now you know the difference between extend and append. Okay, from extend you add the values, number of values as a single separate element, but using append, if you are trying to add multiple values within square bracket, they will be got added as a list only. So that is the difference. Now let's see more commands. Is so del command, so delete command we can perform. Let's say you want to delete some values at any index within the list, so you can do it. You do del L and you provide the index number. So you mention the position which you want to remove. Say 0, 1, 2, 3, 4, 5. 5 I want to erase, means this 8 position, this 8 number I want to erase. Okay. So let's do 5 and run this. Shift enter and let's now read the L. So you don't have 5. So this 8 got deleted. Now after this 5, the second 5 has come. So your list got updated and you have removed that number, you have deleted that number. Okay. Say you want to remove two numbers together. So you can do like delete L. You provide the two index, two numbers. Say I want to remove this 5 and 6. These both the 5 and say I want to remove two numbers, 1, 5 and 8. So I'll give the position 1, 2, 3, 0, 1, 2, 3, 4. Position for this 5, index for this 5 is 5 and for this is 6. So we defined 5. So we are starting from 5 and we are ending at 6. So I'll write 7 because here we don't delete the last number. We don't perform the action on the last number. We perform the action on the number before the one which you have defined. So it will delete the 6th position. So 5 and 6 will get deleted. And let's define L now and shift enter. So those 5 and 8 number both got deleted. So you have 5, 4, 5, 10, 12. Okay. So that's how you do the delete function. Now let's see this one more pop function. So let's see how this pop function works. So we'll perform the function, this action on L list only. So L dot pop bracket. Let's define L now. Let's print this output and shift enter. So see, this is your updated, this is your last list. This is the list L which you have right now. And now after performing this pop function, you got this. Okay. So you can see the difference, right? So this 10, this one element for this big list, L list, this is the nested one and it is working as one element. So pop function does that, it pops out your last element from the list. So if you had the single number here, like let's say, let's perform it again here and shift run. So now you don't have 12. So it pops out your last element. By default, your last element, if you have not defined any index, but if you defined index, let's say 2. So 0, 1, 2. This is the 2 position. So if you define 2 index, let's see how it works. So your element at position at index 2 will get popped out. Okay, so that's how pop works. And you know the difference between delete and pop now. By default, last element will get popped out, and if you define the index, it will remove the specific number. Let's read about this one more, remove. So let's perform it on L and do remove function, and let's remove this physics. Let's define L. Let's see what happened to this L and shift enter. So this physics value got removed. Now the difference between, see, you can also remove this physics with the help of pop after you define the index. So 0, 1, if you write the 1 here, it will remove this, delete this physics. And removed also remove this physics, right? So both the things can work, both function can work. The difference is pops works with index. Remove works with values. Okay, so that is the difference. Let's move to the next, that is sorting your list. Let's define the list here. L is in the bracket, sorry, is equal to in the bracket. Let's define 32, any number you can pick. This is your list which you have defined, and I'll perform this sort function on L dot sort. Okay, now let's see what happened to this L list. So this got sorted, 24 being the minimum number came on the 0 index. Now there are two things when we are dealing with sorting. So one is sort, one is sorted. Let's know the difference between sort and sorted. Let's say we have a list A and we have the elements orange, strawberry, mango. Let's run it. This is the list. Okay. Now let's create one more list where I want to store the output of this A list which has sorted values. So I'll perform this sort on A, and that will get stored in your B list. That is what should be the output. Print. So we defined it in bracket A, and let's also print this B, and let's see the output. So for A, values got sorted and that's stored in A only. In B, no values are available. It did not get stored in B. Okay. Now let's see the sorted one. This is sort. Let's see the sorted. So we have C, and here I want to store this sorted in bracket A. Now let's print A and print C. Let's run this. Let's define this A first again because here it got sorted. And define this A as orange, strawberry, and mango, where values are not sorted. And now run this code. So you see that your A is as it is orange, strawberry, and mango, and C got updated. This is the second command. This is the output of this C, and C has sorted values. This C got updated. So the difference between sort and sorted is when you want to update your current list, original list, then I'll use sort. And when I want to sort my values of current list, but I want to store it in another list, I want to keep my current list intact, I don't want to change anything, there we use sorted. Okay. Now let's read about the next one, that is shadow copying. So let's see how this shadow copying works. So let's say I have this list only. I copy this list, paste it here, and let's run A, shift enter. So this is my list. Now let's create another list B, which should be equal to A. So let's print B now and see the output. So now your B is equal to A. This is the output of A list and this is the output of B list. Okay. Now let's say I want to update this orange with apple in the A list. So let's say A in the A list. So I want to replace this orange with apple, and now let's see the output of both. Print A and B. Let's see the output for both. Shift enter. See, this is A and this is B. So You see, I updated the value only on A, but it happened on B too. Okay. When you do A is equal to B, this shadow copying happens. Means whatever operation you do on any of the list, it will affect other list also. Okay. The same operation will get operated on the other list as well. But there's option we can avoid this, where we can do like we perform one action on the list, but it doesn't affect the another one. So there's an option. Let's first see the list A, B. See, this is your list. Now let's see how we can ignore this shadow copying thing. So if you do B is equal to A, and in the bracket, if you define this column, then your shadow copying will execute. Now let's see, run this. Now let's update the value at one position. This is strawberry. This is 0. This is 1. I want to update gray. Okay. And print A and B. So I updated the value. I'm trying to update the value, the element at the position 1 in list A, and we are going to see whether it updates only in A or that happens in B too. So let's run. So this is your A and this is your B, and you can see that grape, this strawberry got replaced with grape only in the A list, not in the B list. So that happened because of this instruction. So this command. So if you want that only one list changes, the only the list where you are performing the actions, only that get updated. So there you do this one. And if you want the shadow copy, so you can simply write A is equal to B. So that's how we do shadow copy. So this was all about the list, and these were the few commands which we can perform. But you don't stop practicing. You go write the code on your Jupyter notebook and ask me if you have any doubts. Let me know in the comment section. Keep writing the code. So that's all. Thank you so much for staying with me and have a good day. Bye bye. I'll meet you in the next video.